right, so get this right. There's this brand new research paper, like just came out January 8th, 2025, and it's going after this huge question. Can we, actually teach AI to think more like us humans do?
Not just, doing calculations or spitting out text, but really like deliberate problem solving.
That's exactly it. And the paper, it's called Toward System 2 Reasoning in LLMs, Learning How to Think with Meta-Chain of Thought, suggests that we might actually be able to do that.
Yeah, it dives deep into those large language models, LLMs.
The things behind, like, probably the chatbot you're using right now as we speak.
Right.
Okay, so this deep dive, it's all about getting a handle on this new approach, this meta-chain of thought, Meta-CoT,
Meta-CoT, yeah.
and seeing if it, lives up to the hype. The paper, it starts by pointing out this problem. You're probably not going to be surprised by this. Even the most, cutting-edge AI today
Right.
struggles with reasoning that seems super basic to us.
Yeah. Think about it this way. GPT-4
GPT-4,
can answer what is 1 plus 2 instantly, but give it a slightly more complex math problem, even one that breaks down to a straightforward answer, and it just trips up.
it's like it has a recipe but can't, improvise when things get a little tricky.
Yeah. That's where the complexity hypothesis comes in.
Okay, so complexity hypothesis. I'm listening.
And the paper argues that, current AI, even with its chain of thought process where it generates a step-by-step solution,
Right.
it hits a wall when a problem needs something more than just linear thinking.
I see.
Imagine navigating a maze, right? You might need to backtrack, explore different paths, even just completely change your strategy.
Oh, okay.
And AI isn't very good at that dynamic problem solving.
So if current AI is following a set of instructions,
Right.
this Meta-CoT is more like giving AI a mental map and a compass.
Exactly.
It's like equipping it to think through the problem, not just follow, pre-programmed steps.
Meta-CoT models the reasoning process itself. It brings in search, which is where the AI checks out different reasoning paths and evaluates them, sees what their potential is before it commits to one solution.
So is that more like how our brains work?
Yeah.
We don't always solve things in a straight line. We
Right.
try things out, we make mistakes, we adjust our thinking, as we go.
And the paper's figure 1, it really shows this. It shows how AI performance just drops on a really challenging math benchmark as the problems get tougher.
Oh, wow.
You can see the limitations right there.
It makes you wonder if that's why, some AI answers can feel a bit off.
Yeah.
Maybe the AI got the right answer, but it took some weird roundabout way to get there.
That's a good point. And that leads us to a really important question, which is how do you actually train AI to do this Meta-CoT thing?
Yeah, how do you?
Well, one method the paper explores is something called the self-taught reasoner, or STAR.
Self-taught reasoner, okay. Sounds intense.
It's more like AI practice, but
Yeah.
it's got a coach who only focuses on the good plays. So the AI generates solutions to a problem, and then there's this behind-the-scenes coach that verifies the right ones, and the AI learns from those successes.
So no hand-holding. Just here's what you did right, now go figure out the rest.
Yeah.
That's pretty smart, I gotta say.
Yeah.
Does this tie into, that whole meta-reinforcement learning thing?
Yeah, it totally does.
Which I keep hearing about.
Meta-reinforcement learning, it takes it even further. Instead of just, learning what to learn, the AI learns how to learn.
Whoa.
So imagine AI discovering entirely new ways of reasoning, going beyond, even what humans have come up with.
Okay, that is where it starts to feel like we're stepping into, sci-fi territory.
A little bit, yeah.
AI teaching itself to think in ways that we haven't even thought of. It's kind of exciting, a little bit daunting.
Right.
Yeah. But the paper presents some really interesting findings about Meta-CoT that might make you feel a bit better.
Okay.
So for one, models trained with this Meta-CoT aren't just more accurate, they can actually be more efficient too.
Yeah.
So it's not just about being smarter.
Right.
It's about being smarter and faster.
Exactly.
Okay, that is intriguing.
And this efficiency shows up in some cool ways. Figure 8C shows how Meta-CoT models do great at maze solving. And the bigger the maze, the more complex the maze, the better Meta-CoT does.
So bigger challenge, the better Meta-CoT does.
Exactly. It kind of hints that this approach has serious potential for those really tough problems.
It's like those AI-powered navigation apps.
Yeah. Yeah.
But on another level.
Yeah.
Not just finding the shortest route, but adapting to all those crazy detours and stuff. Pretty cool. But I gotta ask, if this works so well, why isn't everyone using it? What's the catch?
Well, to be honest, training these models is Very expensive. We're
Okay.
talking massive data sets,
Yeah.
serious processing power.
Not something you can just, like, whip up on your laptop?
No, not really.
Okay.
And even with all those resources, we're still trying to figure out how to evaluate AI's reasoning,
Yeah.
especially for open-ended problems, like where there isn't a clear right or wrong answer. Like imagine proving some crazy math theorem.
Oh, yeah, I see. So it's not just about the AI getting the right answer.
Right.
It's about understanding how it got there and if that thinking holds up. But people are working on this,
It's
right?
absolutely.
Trying to overcome these limitations.
Yeah, the paper talks about a project called Big Math,
Okay,
which aims to create like these giant data sets to train Meta-CoT models. But
okay.
it's not just about answers, it's about the detailed steps of reasoning.
So big math is like creating a training manual for like AI detectives,
Mm,
teaching them not only to solve the case, but to show their work.
exactly.
That's awesome. Anything else on the horizon?
Well, there's another really interesting direction that the paper mentions. It's called Search 2.
Okay, search us.
And imagine AI learning to like manage its own resources for reasoning,
Mhm.
potentially getting over those limitations of like how much it can think about at once and how much computing power it needs.
AI that can budget its own thinking time. That's wild. It really feels like we're on the edge of some major breakthroughs in like how AI reasons.
It really does.
But before we get too carried away, I'm curious. What does all of this mean for us, the people who are interacting with these increasingly smart machines?
It's the big question, isn't it?
Yeah.
I think if we zoom out and look at the big picture, this whole Meta-CoT thing, it's a step towards making AI more like us.
More human-like.
Yeah, it's early, but the potential is huge. Like imagine AI that can not only plan experiments, but design brand new technologies or even help us understand like really complex social problems.
That's exciting. And a little bit, unnerving.
Yeah,
AI that can think like us, reason like us, maybe even outsmart us in a way. It's like something straight out of sci-fi, but it's becoming more real every day.
it really is. And that leads us to this really thought-provoking question that the paper ends with.
I like those.
Will this Meta-CoT just make AI more efficient? Or will it, unlock these completely new levels of intelligence?
Mhm.
It's something to really think about as we continue to, like, explore this super fast evolving world of AI reasoning.
We are going to ponder that.
Yes.
But for now, we're going to take a pause and let all of this sink in. We've covered a lot in this first part of our deep dive.
Definitely. When we come back in part 2, we're going to delve into some of those really new and interesting ways researchers are training these AI systems to, think more effectively.
Stay tuned. Okay, so welcome back. Last time we were talking about how to train AI to actually do this meta chain of thought thing. And it seems like, getting AI to think more like us could be pretty game-changing.
Oh, yeah, absolutely. And that's where things get, even more interesting. The paper, it explores some seriously innovative directions for training AI to reason better. And one of the most promising ones is this idea of like synthetic Meta-CoT.
Synthetic Meta-CoT? No, okay, now you're going to have to break this one down for me. Are we talking about like creating a whole virtual world where AI can practice thinking?
You're actually on the right track. It's about, moving beyond just using examples of human reasoning.
Hmm.
Because it's really hard to capture like all the complexity of how we think in a data set, right?
Yeah, for sure.
So researchers are turning to these things called search algorithms to automatically generate tons of training data.
Wait, search algorithms? Like the ones that power Google?
Yeah.
Or, help us find the best route on a map. What do those have to do with AI reasoning?
Well, those algorithms, they're really good at like exploring possibilities and finding the best solution
Okay.
based on certain, criteria. And in this case, instead of searching for websites or directions, they're searching for solutions to problems.
Ah, I see.
The AI basically uses these algorithms to try out different ways of reasoning. It's generating those step-by-step solutions that can then be used to train other AI models.
It's kind of like crowdsourcing AI thinking. But instead of a bunch of humans, it's a bunch of algorithms all working together to make this massive library of like problem-solving strategies.
That is a great way to put it. And the paper, it goes into two specific types of these search algorithms that work really well for this.
Yep.
Monte Carlo tree search, MCTS.
MCTS. Okay.
That's a search.
Those sound familiar. Aren't those the same algorithms that like power game-playing AI,
Yeah.
like for chess and Go, stuff like that.
They are.
Yeah.
Both MCTS and A-Search, they're used in AI for all sorts of games. Chess, Go, even video games.
Okay.
The idea is that the AI tries out like a huge number of possible moves or actions.
Right.
And then it evaluates what could happen with each one.
Okay.
And then it chooses the best way forward.
So are we basically setting up AI to play games against itself?
Kinda, yeah. By using these game-playing techniques for reasoning, researchers are basically turning problem-solving into a game for AI to win.
Master, yeah.
And it's actually working.
Any like specific examples where this is working well?
Yeah, the paper gives a couple of really interesting ones. Like, researchers have used this MCTS to train AI to solve logic puzzles.
Oh, wow.
And even play that game Countdown.
Countdown. You wouldn't think AI would be good at that.
Yeah.
But I guess this synthetic Meta-CoT is changing things.
It really is. And the AI, they're not just solving problems, they're doing it more efficiently than the old ways. It's like they're finding these really elegant solutions, getting to the heart of the problem.
That's cool. So with synthetic Meta-CoT, we're training AI to be more like a seasoned problem solver. You know, finding that elegant solution instead of just brute forcing it.
Exactly. But there's another layer here that I found really interesting.
Okay.
When researchers started looking at the reasoning traces that these AIs were generating,
Yeah.
they found some surprising patterns.
Reasoning traces, those are the step-by-step breakdowns of how the AI is thinking, right?
That's right. And what they noticed was these traces, they often show things like, sudden shifts in logic, repeating ideas, even what they call semantic backtracking.
Semantic backtracking.
Where the AI basically goes back and looks at old ideas again.
So it's like the AI is second-guessing itself.
Yeah. Kind of like how we approach a tough problem sometimes, right?
Totally. We don't always think in a straight line.
Exactly.
We hit dead ends, circle back.
Right.
Sometimes, we even mess up, and it leads to a better solution.
Yeah. And so the paper suggests that those moments of backtracking and repetition in the AI's thinking, those things that seem like inefficiencies, might actually be signs of a more, sophisticated approach.
So it's like those moments where I feel stuck on a problem.
Yeah.
It's less frustrating knowing that even AI is struggling with the same stuff.
Totally. But of course, even with these fancy search algorithms and the potential of this synthetic Meta-CoT, there's still a piece missing.
What's that?
The AI needs feedback. It needs some way to know if it's on track and how to get better at reasoning.
Right, that makes sense. It's like having a student who's learned all these concepts,
Yeah.
but they haven't actually applied them or gotten any feedback. They need to know if they're understanding things and how to, refine their thinking.
Exactly. And that's where these process reward models, or PRMs, come in.
Okay, process reward models,
Yes,
PRMs.
PRMs, tell me more.
Think of them like an internal critic for the AI. But instead of judging just the final answer,
Okay.
they're giving feedback on each step along the way.
Gotcha.
It's not just about getting the right answer, it's about getting there in a way that, logically makes sense.
So it's like having a writing coach,
Yeah.
who not only checks your grammar and spelling, but also helps you refine your argument, make sure your ideas flow well.
Perfect analogy.
Mhm.
So these PRMs, they're trained to assess each step,
I see.
rewarding the good ones, the ones that lead to the right answer,
Yeah.
and, penalizing the ones that go off track.
And what's really exciting is that this opens up ways to train AI to reason on those open-ended problems where there might not be one single right answer.
Right, like in, scientific research.
Yes.
Or like legal arguments, where the reasoning, how you get there, is just as important as the final answer.
Exactly. And it gets even better. You can actually use these PRMs to train AI to find and fix its own errors.
Wait, hold on. We're talking about AI that can spot its own mistakes and fix them. That sounds like some next-level stuff.
Yeah. It may sound like sci-fi, but the research is showing it might be possible. The paper points to studies where AI models not only learn to recognize errors,
Oh, yeah.
but they actually come up with alternative solutions, like they're revising their own thinking as they go.
Okay, that is impressive. It's like a student who can not only catch their own mistakes on a test, but then figure out the right answer without the teacher's help.
Exactly.
It feels like AI is getting way more autonomous and reliable.
It really does. And think about it. If AI systems can learn from their mistakes and get better without us constantly supervising them, that changes how we can use them in our lives.
It would definitely make me feel better knowing that the AI I'm using can, self-correct.
Mhm.
But I'm guessing training these PRMs isn't easy, right?
It's definitely complicated.
Yeah.
You need a lot of data
Mm-hmm.
and a really well-designed training process to make sure the AI is getting feedback that actually helps.
Hmm.
It's like designing a curriculum for a school for AI thinkers. Got to make sure they're challenged, engaged, and learning effectively.
I like that analogy.
Yeah.
So what are people doing to, overcome those challenges? What's on the horizon?
One of the most exciting directions is using something called reinforcement learning to train these PRMs.
Reinforcement learning. Isn't that how AI beat the world champions at Go and chess?
Yeah, it's a really powerful way of training AI to learn through trial and error.
Right.
Getting rewards for good moves and
Yep.
penalties for bad ones. And now researchers are applying that to AI reasoning.
So instead of playing a game of Go,
Right.
the AI is playing a game of, reasoning effectively, exploring strategies, getting feedback, and learning to think in ways that get results.
Exactly. It's like setting up a training ground for AI detectives where they can practice solving cases, get feedback on their methods, and really hone their skills.
I love that.
Yeah.
So I'm guessing the early results look good.
They do. Researchers are finding that reinforcement learning can really boost how well and how accurately AI can reason, even on those really complex, open-ended problems. It's a super promising direction that could lead to some major advancements. But, as we go deeper into this research, there's something even more incredible starting to show up.
Okay, what's that?
The possibility of, meta-reasoning in AI.
Meta-reasoning. Okay, now we're getting into, seriously mind-bending territory.
We are. Meta-reasoning is basically the ability to think about your own thinking, like monitoring and controlling your own thought processes.
Okay.
And that's considered, like a key feature of human intelligence.
So are we talking about AI that can actually introspect, reflect on its own thoughts?
Yeah. It's a question that's stirring up a lot of debate right now.
Right.
We might not be at the point where AI is having an existential crisis or anything,
Right.
but the research is definitely pointing to some interesting possibilities.
Okay, so what kind of meta-reasoning behaviors are we seeing?
Well, for one, there are models that can estimate how confident they are in their answers.
Oh, wow.
It's like they can say, I think I'm right, but I'm not totally sure. And then there are models that can change their reasoning strategies based on how hard the problem is.
So they're deciding when to, put in more effort and when to go with a simpler approach.
Exactly.
That sounds like a level of self-awareness and strategic thinking. That's pretty incredible.
It is. And these meta-reasoning abilities, they're not just coming from specific programming, they're emerging from the training process itself.
So as the AI gets exposed to more complex problems and gets feedback, it starts to understand its own thinking better.
Exactly. It really does feel like we're seeing a huge leap forward in AI. But it also brings up some big questions. Like, if AI is getting more human-like in how it reasons, how will that change how we interact with it?
Right.
How will it change our world?
Those are the million-dollar questions.
They are. And those are the ones we'll dig into in the last part of our deep dive. But for now, I think it's safe to say that this whole world of AI reasoning, it's changing fast.
Yeah.
And the future holds some seriously mind-blowing possibilities.
I'm ready to be mind-blown. Let's take a quick break and come back for the final part of our deep dive. We'll tackle those big-picture questions about the impact of all this and what's next for AI. All right, welcome back to the deep dive. So we've gone pretty deep into this meta chain of thought thing, and now I think it's time for the big question. What does this all mean for the future? What are the implications for us, for society, for, even the very idea of intelligence?
That's a question that the paper really wrestles with. The authors, they argue that the way we're evaluating AI now, with its focus on these specific tasks like solving math problems or generating text, it's just not enough.
Not enough to really grasp what Meta-CoT can do.
Exactly. They propose this thing called the Big Math Project.
Big math.
It's a huge data set of seriously challenging math problems designed to push AI reasoning to its limits.
So it's not just about getting the right answers.
Right.
It's about forcing AI to think strategically, to backtrack, adapt, engage in that kind of complex thinking that we usually associate with, us.
Exactly. It's almost like, setting up an obstacle course for the AI's mind.
I like that, an obstacle course.
Yeah.
Testing its ability to navigate all those twists and turns.
Yeah, exactly. And, big math, it wouldn't just be useful for AI researchers. It would be valuable for anyone who wants to understand, what intelligence really is.
By studying how AI tackles these tough problems, we can get a better grasp of how we think, too.
Absolutely. It's like, as we teach AI to think more like us, we might actually learn more about ourselves in the process.
That's pretty wild. But, with all this talk of AI getting more and more sophisticated, how do we make sure it's working the way we want it to?
That's a really important point.
If AI is going to be making decisions that impact our life,
Mm,
we need to be able to trust those decisions.
absolutely. And the paper stresses that too. As AI systems become more capable of thinking on their own,
Right?
transparency, being able to see what's going on, that becomes crucial.
We need to understand how it's reaching its conclusions, not just blindly accepting the output.
Right. Like, think about it. It's
Yeah.
the difference between a doctor just telling you what to do
Okay, yeah.
versus a doctor who explains their diagnosis,
Right.
their reasoning, the potential risks and benefits.
You build trust that way. You can make an informed decision.
Exactly. And that's where those reasoning traces come in.
The step-by-step breakdowns.
Yeah. They're like, a window into how the AI is thinking. We can see the path it took to get to the answer, not just the answer itself.
So instead of treating AI like this mysterious black box,
Right.
we can actually look at its reasoning and make sure it makes sense, it's logical, and, aligns with our values.
Exactly. And the paper, it highlights how important it is to develop ways to analyze these reasoning traces, making AI more transparent and accountable.
It's about moving beyond just trusting it blindly, creating a system where both AI and humans can understand and learn from each other.
Yeah, that's a good way to put it.
Okay, there's one more thing I'm curious about. The paper mentioned something about integrating, like, external tools into AI reasoning. What's that all about?
Oh, that's a really cool area. It opens up all sorts of new possibilities for how AI can solve problems. Imagine giving AI access to things like calculators, databases, even the internet.
Wow.
By using these tools, AI could potentially tackle way more complex problems.
It's like giving an AI researcher a fully equipped lab, a huge library, and a whole team of assistants all at once. The potential is pretty amazing.
It really is. But, like with any powerful technology, we got to consider the risks. We have to be super careful about how we design and control these systems. We want them to use these tools responsibly, ethically, and, in a way that aligns with what we value as humans.
We can't just get caught up in the excitement without thinking about the potential downsides.
Exactly. And the authors of the paper, they admit that it's still early days for Meta-CoT.
Yeah,
There's so much more to learn, to figure out.
right.
But the overall feeling is one of, like, cautious optimism.
So it's about finding that balance,
Right.
embracing the potential, but being aware of the risks. That sounds a lot like the story of, well, pretty much every technology,
It
right?
really does. And as we wrap this up, I think the main takeaway is this. Meta chain of thought is a powerful new way to approach AI reasoning. It has the potential to really change our world.
For sure.
But, like with any powerful tool, it's up to us to guide its development and make sure it's used for good.
Well said. We've covered a ton in this deep dive, from the technical stuff about Meta-CoT to the bigger questions it raises about intelligence and our future with AI.
It has been a fascinating conversation.
This has been The Deep Dive. We'll catch you next time as we explore another groundbreaking idea.